Good afternoon, everyone. I'm Peter Kyung from Daesung America. Today, I'm here to talk about Dsavory, our solution for clean label and sodium reduction. Two birds, one stone. Let's jump in. Today's agenda includes introducing our company and Dsavory, our approach to clean label and sodium reduction. Then, Dr. Dave Josephson will wrap up with deeper flavor insight. Let me briefly introduce our company first. Daesung is a fermentation specialized company founded in 1956, and we've been an expert in fermentation for 70 years. That's our legacy. We make everything from food ingredient to finished product, all based on fermentation technologies. That expertise is what made Dsavory possible. We have analyzed how the savory industry has developed over the past decades, and we noticed that every solution had its challenges. MSG and nucleotide, strong umami, but E numbers and bad consumer perceptions. HVP and HAP, better label but sky-high sodium, impurity, and allergens. Yeast extract, almost clean label, but a yeasty off-note and weak flavor delivery. So we decided, let's provide a solution to this. Dsavory takes the good, drop the bad, clean flavor, no carrier, no allergen, and better than just umami. Richer and rounder and more satisfying savory taste. And the label, just natural flavor. That's it. Dsavory is FEMA GRAS certified with 3 profiles. Each profile works at different times in your mouth, like the start, middle, and end of a movie. UH gives you strong upfront flavor. That first wow, when you taste it, the strong immediate flavor right away and with good balance. Great for snack seasonings and sauces. LH gives you deepening the aftertaste. That taste that stays in your mouth after you swallow. The rich, complex savory taste that lasts. Perfect for premium sauces. MH is about roasted meaty flavor during cooking. When you heat it up, you get that grilled meat smell and those roasted notes. Works great with cooking reactions for richer and more real taste. Look at this chart. UH starts strong, right? And LH goes all the way through, and MH comes out when you cook. You can use these alone or mix them together. Your choice, total flexibility. Clean label pressure is real. Has marketing ever asked you, can you take out the MSG, make the label cleaner? Then you think, sure, but what about the taste? You can just remove things. You need a better solution. Look at this slide to see what happens if you use Dsavory. Before, ingredient names that general consumers don't understand, looks like chemistry class. After, natural flavor, done. Dsavory was made for clean label. This isn't losing something. This is getting better. Now, let's look closer at clean label flavor solutions. Dsavory gives you clean label plus richer, cleaner taste. 3 key points to remember. First, you can label it as natural flavor, perfect for clean label trend. Second, no carrier. That means cleaner, richer, and more real taste. Third, you can cut sodium by 25 to 35% without losing taste. This is a really big deal for today's formulations. Now, let's review the real application data. First example, ranch dressing. Everyone loves this stuff. Before, 0.4% MSG added in the finished product. After, 0.5% Dsavory UH. What happened? Strong savory flavor right away, and better herb notes and good balance. MSG aftertaste, gone. Cleaner label, better taste. Second example, nacho cheese chips. before 0.15% MSG in a complex cheese formula, after 0.45% Dsavory UH and LH. UH for first impact, LH for lingering richness. The result, sharper cheese taste and longer umami finish, and more complex and more satisfying taste. Better cheese taste, cleaner label. Third, Alfredo pasta. We replaced 0.06% MSG with 0.09% Dsavory MH. Why MH? Alfredo pasta gets cooked or reheated, so we need a savory, meaty flavor that comes out with heat. The result? Amplified overall flavor, maintained flavor complexity, clean label, and great taste, both done. Now, let's review the sodium reduction solutions. Let's take a look at the US sodium reduction policies and market trend first. FDA is pushing companies to cut sodium step by step. The market already moving. Companies are already using potassium chloride, yeast extract, and natural flavors to complement saltiness. And high sodium products like snack and soups are changing fast. Even school meals are switching to low sodium. Bottom line, sodium reduction is not optional, it's required. So, how do we reduce sodium? Let's look at the traditional ways first. Potassium chloride, cheap alternatives, but use too much, you get metallic taste. Salt-enhancing flavors, results vary, hit or miss honestly. Sea salt, Himalayan pink salt, great for marketing, but doesn't really cut sodium and expensive. So we came up with a better solution, boosting umami. When you boost umami, your brain thinks there's more salt. So you get that salt craving satisfied and cover up the metallic taste of potassium chloride. Let's compare umami sources. MSG is cheap, but not clean label. Consumers don't like it. Tomato has natural glutamic acid and is clean label, but it changes color and flavor. Can use it everywhere. Yeast extract gives different flavors, but has high sodium and off notes. How about natural flavors? Clean flavor, low sodium, and clean label. This is where innovation is happening now. Let me explain why natural savory flavors like Dsavory work so well. Each natural flavor pulls out specific umami compounds like glutamic acid, amino acid, or nucleotide, and you can control when umami hits your mouth, like conducting an orchestra. 3 technical advantages. First, clean flavor. No off notes, no weird aftertaste. No metallic taste, no bitterness. Second, flavor boost. It doesn't just add its own taste. It makes all the other flavors in your product better. Third, very flexible. No usage limit, and you can mix different flavors, and it works with other tools like potassium chloride. From now on, let's just review some application data. To cut 25% sodium in nacho cheese chips, we tested 3 approaches: adding KCl alone, Dsavory alone, and KCl plus Dsavory together, using total 0.45% Dsavory. Let's move on to the next slide and review the sensory results in detail. First, KCl alone in red. KCl brought back some saltiness, but problems are unbalanced flavor and weak cheese flavor, metallic taste, and bad aftertaste. Second, Dsavory UH and LH together in blue. A much better result, and boosted overall flavor and nacho flavor, and longer, stronger aftertaste, and brought back some saltiness. Much closer to full sodium samples than KCl alone. Lastly, KCl plus Dsavory UH and LH all together in purple. This was the best. Something interesting happened. Dsavory and KCl works together. The strongest overall flavor and nacho flavor, and the highest saltiness score, and the best overall taste performance. Here's why it works so well. Dsavory's glutamic acid and nucleotide make your tongue more sensitive, so you can taste enough salt with less sodium. And complex flavor covers up the metallic taste of KCl completely. Second example, garlic cream sauce. The same 25% sodium reduction goal, testing in a dairy product using 0.22% Dsavory MH. Let's take a look at the sensory result on the next slide. We expected Dsavory MH to bring out the roasty meaty notes that comes out when the cream sauce heats up and boosts the natural flavors of ingredients like garlic. The result, really interesting. First, with Dsavory MH in blue, almost same as full sodium samples for aftertaste, garlic flavor, and dairy flavor. Saltier and more flavorful than KCl alone. Next, KCl plus Dsavory MH in purple. The best result, something amazing happened. Overall flavor, saltiness, umami, and aftertaste beat the full sodium samples. And Dsavory MH and KCl works together beautifully. They replace the low salt and even improve the flavor. This is a huge. It's not just keeping the same taste. We proved you can actually make it better while cutting sodium by 25%. Let me wrap this up. Dsavory is a next generation savory solution with some powerful benefits. First, real clean label solution, just natural flavor on the label. Second, no taste loss, actually make the flavor better. Third, proven sodium reduction. 25 to 35% cut possible with the same or better taste. Fourth, 3 profiles you can customize for your needs. Lastly, FEMA certified for your safety. Next, Dr. Dave Josephson will share deeper flavor insight on MH. So after all presentations are done, we are going to take your question. So please hang tight. Thank you so much.
Thank you, Peter. Can you hear me? We're good? Okay, good. So I am Dave Josephson. I've been in the industry about 36 years, working with some of the bigger flavor houses, Givaudan and Firmenich, Hasegawa and Mann. I spent the first 25 years making processed flavors, everything from beef and chicken and pork to grain flavors and chocolate and sweet brown caramel. In the last 15 years, I was really focused on taste modulation. So there's a certain overlap of processed flavors and taste mod. But I retired about 2 years ago, and Peter got a hold of me and wondered if I wanted to help Daesung interpret the results that they were seeing with Dsavory MH. It's the middle H. It's the one that's not up front and lingering, but it's that full body, and it really is a beautiful product for developing these cooked roast notes in savory applications. So I signed on a little over, I guess, a year and a half ago, and we've been looking at the chemistry, and there's a few things that we've discovered outside of the fact that these things are great precursors for savory in general and roast specifically. So if you look at the contents of Dsavory, it's pretty clear there are 2 amino acids that are the most abundant. They're about 22.5% each. It'd be glutamic acid and lysine. And it turns out we're really happy that they're in equal molar or equal concentrations. And the reason is if you overuse the product, one, it becomes more expensive, but the main result is it has too much umami. You know, you've just overdosed the umami effect. If you reduce it down to a good use level, you'll still get this potent and very desirable roast note, but you'll never overuse the product because of this 1-to-1 ratio. The other unique thing about Dsavory MH is there is no cysteine. Well, we're going to review a little bit about savory flavors before we get too deep into the applications. And it's really important to note that three of the most important amino acids in developing meat flavors are glutamic acid, lysine, and cysteine. But we're happy that the cysteine isn't in this product, because if it was, it would fix with that 1-to-1 ratio, and you would lose the flexibility of using this in a wide variety of applications. So the fact that you're getting the roast and the umami coming from one group, and the cysteine would be added separately through many, many different ways to do that, through processed flavors or other ingredients. So let's move on and talk a little bit, review savory flavors in general and what makes MH so unique in this. First thing, there are these 4 dimensions of savory flavors, and the most important really comes down to taste. Plug your nose, you can taste salt, bitter, sour, umami, and saltiness. Release your nose, you taste the aroma. So the taste components are just those 5, and you perceive them when your nose is plugged, and if you release that and you're chewing food, you'll pick up on the aroma compounds. In savory, there are 2 camps of meaty compounds. There's the camp that is derived through sulfur chemistry, and that's where you would use cysteine in a reaction or other sulfur sources. And then there's the camp where, depending on the thermal generation, the amount of time, temperature, and heat, you can generate boiled notes or sauteed notes, or you can drive them all the way to pyrolysis and seared chemistry. And this is where MH really shines. MH, because it has 22.5% glutamic acid in it, if you put it into an application, it's going to deliver umami. You've seen the data that Peter showed you. Umami is inherent in the product. The lysine needs to be activated with heat to kick in, and when it kicks in, this epsilon amino acid will release, and we'll generate these roast notes at low temperature, and then at higher and higher temperatures, searing and grilling, you'll get even pyrolysis and grilled notes and searing notes. So those are the 2 ingredients that are in MH. Of the other 2 dimensions that are important in savory, one being trigeminal, that would be added by the food product developer or by the chef that is preparing the food. So that's pretty straightforward, heat components. And then the fat, if you're knowledgeable in making processed flavors or the chemistry that makes beef or chicken, you realize that species-specific fat is essential. You can make a chicken flavor or a beef flavor without that species-specific fat, but it'll be a generic meat profile. If you put beef fat into a beef reaction, then you're making really authentic beef, and we'll talk a little bit about that in the next couple of slides. Okay, so there's a couple examples. If you eat sashimi and if you eat beef tartare, there's no heat, and yet we eat these things raw and they're tasty. But largely, you're attracted to that profile because of the taste components, because of the umami. And depending on how you prepare it, there may be some salt on that. But for the most part, it's a very few raw applications in the area of savory, and specifically in meat. Why? Because we've become accustomed to cook our meat. And that cooking can be a process as simple as boiling, or more complex, where you might deploy 300 degree plus temperatures to saute, or even go 500 and 600 degrees for very short periods of time to grill or sear or braise products. And then there's a third process that's used in the industry where you would run the reaction under pressure. So the top one here, it's open, water's boiling at 100 degrees, the reactions are run at 95. When you close that top, you can run these up to 180 legally, but no one does, it's too hot. 120 to 130 is the sweet spot. Run these reactions for an hour to 2 hours, and you're making beef flavor. You're making beef flavor from ingredients that have they're connected to beef because of a precursor relationship, but they have no taste of beef. So in the industry, when you're making a processed flavor that is beef, chicken, pork, you're taking ingredients that are devoid of savory flavor, and through these reactions that we'll talk a little bit about, Maillard specifically, you're developing these meat flavors. In all these reactions, you'll get sugar degradations in this Maillard chemistry, and it's important and it's fundamental to meat. But if you're looking at sauteed notes or grilled notes or seared notes, you need to increase the temperature. And in there, you're starting to look more at lipid decomposition, which then reacts with the epsilon amino group coming from lysine and producing these heterocycles that are really defining roast and seared and pyrolysis, et cetera. Okay. So just in a quick summary of this, we're really happy that glutamic acid and lysine are in this 1-to-1 ratio because of the fact that you can use just enough to get this really desirable meat and roast notes, but not so much that it's over umami. And the fact that cysteine is not in this product gives you the ultimate flexibility. So two are fixed and one's the variable, and you can change that variable based on the end target profile. Okay, so now let's talk a little bit about some of the applications. This is some of the first data that was created where Dsavory MH was put into a vegetable bouillon, and there's no heat involved. It was just added to the bouillon. And it's clear that you see that there's an increase in round body. That's a mouthfeel component, umami, saltiness over overall flavor intensity. But over here at 2 o'clock, you see there's a bump in meaty profile. Well, you just heard me tell you that you need thermal reactions to generate meat flavor. And here you are adding MH to vegetable bouillon, and it increases the meatiness. I'm going to hold that for a little bit, and I'm going to talk about that in the next several slides. But it's a pretty important description of what happens when MH is put into an application without heat. So what we wanted to do is we wanted to demonstrate to our customers that MH had unique properties. And in a reaction flavor, you might take 10 or 15 ingredients and react those under a time temperature sequence. And you don't really know which amino acid or which component is driving the totality of what you're tasting. So we made a decision to take a vegetable source or a meat source, protein source, and react it with one thing, Dsavory. And if you react it with Dsavory, then the difference between the control and the test is the effect of the Dsavory MH. So taking garlic and all of these sources, whether it was garlic or the beef, and in the next couple slides there'll be some seafood examples, we slurry that product, and that slurry then has 1% Dsavory added to it, and it's reacted at 120 degrees for 30 minutes, and we assess control versus test. At 1% MH added to 75% garlic and reacted at 120 degrees, it's too strong. The sulfur chemistry that would represent itself as garlic was described as sulfury because it was just too strong. But this is the aha moment. All of a sudden, you're making a product on the skillet where maybe you would use 0.1% on the skillet or 0.2%, but we're trying to exaggerate it to really see the effect. And 1% is too high, but it's beginning to suggest that you could make a process flavor. And in the industry, you make process flavors 100x so that you can use them at 1%, or 200x so you can use them at 0.5% in an application. So then we made some reactions. It's on the far left here where we bumped the Dsavory up to 10%. And Dsavory at 10% in a model of garlic creates a flavor now, a process flavor that you could use at 0.1 or 0.2% in an application. So Dsavory MH can be used both on the culinary level with a chef reacting on the skillet, and it can also be used as a strategic ingredient for making a process flavor. Same thing happens with beef and chicken. Okay, so with the beef, one component that I want to talk about here is the sulfury. The sulfury is something that we've discovered with all the meat products is MH enhances the meaty component in savory. It provides and delivers umami, it creates roast, but it enhances the meaty component of beef, the beefy component of beef, the chicken component of chicken. So you can see here at 7 o'clock, you get this bump in the beefy profile in this spider chart. It's the equivalent of that sulfury profile in the garlic. All of those were run at 120 degrees for 30 minutes. Same thing with the seafood. And in all cases, you get an increase in saltiness and increase in umami. Now remember, we're adding umami because the MH contains 22.5% glutamic acid. But again, you get a bump out in the shrimp taste or the crab taste, so it's enhancing that protein source or that meat source. And it's also, remember that seafood has a lot of 5' nucleotides. So with these 5' nucleotides, they have a lingering effect. You get both an increase in umami when you do the reaction, but you also get an increase in lingering, and the lingering is the MH. There's a modulating effect and a addition effect. So MH adds umami, but the lysine can cyclize and form a taste modulator, and that taste modulator is enhancing umami and enhancing specifically the 5' nucleotide, and therefore you get more lingering. It's not as complicated as I'm trying to make it sound. MH delivers umami, and MH has the chemistry that when heated delivers a taste boosting or enhancing, or what I would call a taste modulating effect. The aha moment here, which was quite interesting, is whether it's fish or shrimp or crab, there's these group of compounds that are responsible for the odor of seafood. They're alpha-beta unsaturated carbonyls. And that epsilon amino group reacts with them. We're surmising, I think this is the mechanism. And it quenches them, it removes them from the profile. So when you take crab and shrimp that has been frozen and you slurry it, there's this slight stale character to it. You would call it not fresh. And in a reaction with 1% Dsavory for 30 minutes at 120 degrees, you eliminate that stale off negative seafood profile, and you really create what would be considered authentic shrimp and authentic crab like it's coming off the boat. We've put this in front of many customers, and that's their response. It really brings out this authentic seafood profile. So this was good. And this leads us to believe, and we've done some testing with it, where you can add this to things like venison or pork, and you can suppress some of the off taste or off flavor in those applications as well. Okay, so it's not limited to model systems. You know, Peter showed you some real life applications, and now I'm going to show you a couple of applications as well. So we wanted those models to show that it was Dsavory driving that chemistry, and it wasn't 5 other ingredients that you might put into a processed flavor. In this case, we would have a chef just take Dsavory at 1% or 0.5% or lower and put them into a meat patty or a sausage and cook them on the grill. And what's important here is at 1% it's too strong, but at 1% you could dilute it by 50% and you have a product that tastes great. So why dilute it? Why dilute beef with beef when you can dilute beef with soybean or with pea pod? So in the end of the day, this is going to be a really good application where you take Dsavory MH and you dose it into an extended meat patty. What we discovered, I have beef sausage here, but when we did pork sausage, breakfast pork sausage, the MH also enhances the seasoning blend. So you get, in addition to this really nice, desirable sausage patty, you get this enhancement of the seasoning. Just like you see, there's an enhancement of different flavor components when you see MH in various food applications. So then Daesung contracted with Matson here in California, and they ran a series of applications and screened the best and did a lot of sensory analysis on them. And we're just highlighting 2 here, and then I'll talk a little bit about some additional work that was done with the beef empanada. So at 0.27%, when the MH was added to this product, it delivers this roundness in roasted meaty depth, as Peter was talking about, and it's quite interesting to note and see. It lifts the tomato and the beef notes. It's not just lifting the profile. You feel that whole flavor system lift, just like in those model systems where it enhances the meat component, enhances the tomato component, enhances the spice component. But the aha moment for me was this buttery crust. When Matson created this product, they had butter in the crust, but it was at a level where with the control you didn't taste the butter. And with MH at 0.27%, that butter turns out to be a brown butter, and it's really remarkable. So we've gone beyond that, and we've made butter biscuits and butter cookies, and it really enhances the butter component when the butter is at a threshold that is not perceivable in the application. So for any of you product developers, if you are product developers, you're using butter, you can reduce your butter immediately by 50% and supplement it with MH, and you're going to get nice roast notes, and you're going to get really nice brown butter notes, which is hard to do in this industry. Okay, so then garlic chicken pasta. same thing. It amplifies the savory impact of the chicken and the garlic and the parm. So when you're tasting it, the flavor's more alive. It's less heterogenic and it's more alive. You're tasting all these components in the product, and it seems to be, more zest, more peak. I will say that the MH will modulate or reduce some of the acidity. So if you have a product that you're struggling with that is just too acidic, the MH really softens and rounds that product out very nicely. Okay, so in review, I didn't start off the conversation, but I should have started off the conversation by saying that this is a dual fermentation. There's two bacteria that ferment raw sugar. And in doing that, the rules are that this can be labeled as a natural flavor. So Dsavory LH, Dsavory UH, and Dsavory MH are all labeled as natural flavors. Well, that's a huge advantage because you're not labeling the typical umami components that people would use, which would be MSG and 5' nucleotides. Daesung warehouses this in 3 locations, here in California, in Chicago, and back in New Jersey. So there's a ready supply available for all of the Dsavory. And then why is it that this product, MH, that we've been talking about today is so desirable for savory? It drives this richness and this potentiation of the protein source, and it seems, now I may be exaggerating this a little bit, but I've seen applications where it seems to slightly increase the umami, slightly increase the saltiness, slightly increase the sweetness, for example, in the 5' nucleotides, suppress bitter, and suppress metallic. And that is pretty remarkable. That's like yummy, if we can use that word. If it was in a beverage, you'd call it gulpable. It's something that's very desirable and hard to find in a single ingredient that's really rounding and improving and making these taste very, very authentic. So this basic summary is the MH is inherently umami because it's 22.5% glutamic acid. That's labeled as natural flavor. There's a salt taste modulation. We see salt amplification, probably because when you heat glutamic acid, it cyclizes and forms pyroglutamic acid. It's a known taste modulator that enhances salt. It can also be the fact that the umami, both 5' nucleotide and MSG, synergistically work together to help amplify that sodium impact. And then it's super unique because it's got this blend of glutamic acid and lysine, which when heated at the right temperatures and time produces this really desirable roast note, which then if you push it a little bit further, you can get seared chemistry from that and pyrolyzed chemistry and get a whole range of thermally processed meats. And then a fourth one, if we wanted to put a fourth one in there, it seems like in seafood, at the right conditions, if a product is spoiled and stale beyond, I don't know that it's going to help, but if it's a frozen product that's got a slight fishiness to it, this will remove that fishiness, and we've gotten a lot of feedback from customers saying it really tastes authentic and more like it's coming off the boat. So that's the summary of MH, and I think we're going to take questions. Are there any questions? Is anyone in the audience make flavors? Does anyone create? It's all health. Okay, let's talk about the health. Low sodium. Go ahead.
Great presentation. Can you in the beginning of the slides, you mentioned about that MH and then a few others, kind of the part of this one. Can you talk a little bit about those two as well?
Yeah, we can. Do you want to talk about LH and UH, or do you want me to?
Oh, sure.
Okay. Okay, so I'm just going to stand a little easier. You want to go back to that slide?
You don't need to.
Let's just go back so everybody can see what we're. So the UH and the MH are, the UH and the LH are also fermented on raw sugar. It's this slide here. So they're also fermented single organism raw sugar, labeled as natural flavors. The target for UH is at upfront mouthfeel, and it's designed, the bacteria with that sugar source produces some glutamic acid. So it's defined to give you upfront hit of umami. And the LH is designed to deliver the 5' nucleotide load. So you're able to deliver this umami complex using both, and there's a synergy when you use both. And then the MH on top of that delivers additional umami, plus the salt potentiating, plus the lysine that drives a lot of the chemistry that allows you to define the savory application of something that's been roasted or been grilled or has been sauteed. Okay, does that answer your question? Yeah. Okay, thank you. Yeah, you stand here.
Thanks for the presentation. It was really good. So most of the examples you gave seem to be around meat applications. Just curious if you've done any work along the lines of plant-based meat applications. How did it perform?
Say the other application.
Plant-based.
Oh, plant-based.
Yeah.
Yeah. It's something that Daesung is working on and some of our customers are working on, but we've done less work with it. Less. Yeah. There is definitely hope that we're able to block or mask some of the P character of P, but it's not complete yet. So that's ongoing. It's a great question. It's something we did do some work with masking the off character of pork and the off character of venison, and it works just like it did with the seafood. But you know, the P chemistry is very different than that. Yeah.
Hi, thank you. Really good job. I'm glad to see the non-GMO butterfly up there and that you're using natural flavor, but I think I can speak for everyone in the room that when you put natural flavor on an ingredient panel, that is now signaling to consumers that it is a highly synthetic, typically synthetic biology ferment using gene-edited vectors, a pathogen or E. coli or a yeast. I think I'd like to just hear your comment about how to get around using natural flavor because it's now a trigger word as opposed to something that's reassuring.
Yeah.
We see me disagreements, but go ahead.
Well, you know, it's nothing that I've talked to Daesung about, so I'm giving you my opinion. I'm not giving Daesung's opinion here. This is an educational issue. When you take two bacteria and you let them grow on raw sugar cane, and there's no synthetic added at all, and it's all done under typical fermentation characteristics, that product is as natural as going out to a honey hive and pulling some of the honey that's not quite complete yet, and it's just, you know, it's starting to concentrate. I mean, it's as natural as can be. So this product is natural. And there's no synthetic and there's no contaminant or something toxic in it. So it's an educational thing, for sure, in my opinion. Well, the question is, how can you label that doesn't say natural flavor? Because natural flavor triggers with some people.
Yeah. To add some comments, you know, can you hear me? Actually, in order to be claimed as natural flavor, we need to meet three conditions. Firstly, we need to use non-GMO strain to ferment. And second one is we need to use natural ingredients. And then lastly, we need to use natural process. So process, ingredient, and strain should be all meet the natural flavor some requirement.
Great presentation, by the way. Very insightful. My question would be, you kind of mentioned that there's no carrier in these type of flavorings. My curiosity would be then, like, what is the implications in terms of like the stability of these flavors? Like, can they last long? You kind of mentioned briefly at the end that it's typically like used in frozen products, but what about like some other products like snacks that has to be like maintaining their shelf life for a long time? What's the implication for that for these type of flavorings?
Okay, so what I heard was that it's dried on itself, there's no carrier, that's true. And then what was the middle part of your question?
Yeah, so I was just curious about like the stability in terms of like the shelf life as well. Like, do they last long, and are they applicable to like snacks and more like packaged foods?
Right. Okay, so the unique thing about this, it's a fermentation, it is largely protein, 67.67% protein. It's pretty stable. Now there's a 19% carbohydrate, and that's a spent carbohydrate. That's not sucrose and glucose and fructose. I mean, it starts with sucrose, but some of it can invert, but the bugs chew all that up. So you've got a really stable source to begin with because it's protein-based. There's no fat in the system, so that's a big advantage. And the product is dried, and then you're not vacuum packaging this, but it's stored in an ambient temperature, but nothing that's going to go too high. And you got a 1 year shelf life or 2 years? 2 year shelf life. So 2 years is a long bit of time. But mainly it's because the backbone is protein. Yep. Okay.
Does it have an effect on texture of whatever component it's being added to, especially if it's a protein?
No, not too much. Actually, it is not for the texture, mainly for just the improving the savory taste.
So let me add that at 0.27 in the empanada, 0.27% is pretty low. Although it's a lot of amino acids, free amino acids, it doesn't have that protein structure that could lend itself if used at 2 and 3 and 4 and 5%. When I put these in reactions at 10% or 1%, that product was then tasted at something like 0.1. You're never tasting the full product because it is too strong. We're trying to make a concentrate so then we can leverage it as a flavor or encourage a flavor company to use it to do that. Yeah, so it's a pretty small dose that you're consuming.
Hi.
Hi.
I have a question regarding regulation. So this product is already GRAS approved. It's a self-GRAS, FDA GRAS.
Oh, you're right. You're right. Actually, it is not the FDA. However, we already got self-formed GRAS and plus the FEMA GRAS. FEMA. Our products are all FEMA GRAS certified now.
Generally recognized as safe. Yeah, and there are flavor companies, large flavor companies that are working with these products and using them. So if you want to know if it's safe, the big flavor companies won't touch this stuff until you go through all of that. Has anybody here worked for any big flavor company? I mean, I don't know what it's like in the food industry, but the flavor companies are rabid about making sure that they have no liability. So you can count on it being generally recognized as safe. Yep.
So you obtain the product or the ingredient. Are you doing some heat treatment to the ingredient, to the powder, so it's considered ready to eat?
Is the question?
It's a kill step. Does it have a kill step?
It's hard for me to hear. I'm sorry.
The ingredient has a kill step during its production. So
Oh,
can
you mean
it be
kill
considered
step.
a ready to eat
Oh, yeah,
ingredient?
kills that. Actually, during the process, we have some drying process, which is over 60 degrees, and then even though there's some sterilization through the drying process, we can control it, and then also in final product, we control all the microbiological the items. So, yeah.
Good questions.
Okay.
It's good. Thank you so much.
Thank you so
Appreciate
much.
it.